Okay, for 7, 6, we are going to have a little warm up here. So please pause the video and go ahead and go through those. And then we'll dive into the material. So for this warm up, we were just going to do with the first one, we would add multiply, right? It's parentheses, you feel like you would distribute. Also, a reminder, we can't have a negative exponent. We need to throw that into the denominator. And the last one, we would subtract, so we would 3, and that would go in the numerator because the larger one is out. Now, the same rules apply when you start throwing in fractions. So we would have x to the 4 over 2, we would add these, and 4 over 2 is 2, so it would be x squared. The next one, we would multiply them, so we would get 6 over 20, which does reduce to 3 over 10. And then our last one, or our last two, same way as the ones above, right? If I want it to be positive, I would put it in the denominator. And over here, we would subtract, so 2/3 minus 1/3 is 1/3, and that would be in the numerator, because that is where the larger one's at, okay? So we are going to focus today on fraction exponents. Exponents that are actually the number on the matches the number on the bottom. Okay, so essentially, I just wrote that all wrong. So essentially, what happens is whatever is the exponent, like the numerator, just stays with it on the inside. Okay, so the bottom one is back and forth. And this actually makes sense. So if you think about so far, we've done 3 and then like x to the 6. We know this becomes x squared, right? Because we would divide by 3. That's because it gets rewritten this way. Okay, so you take that outside and you throw it underneath. Okay, or vice versa. So for this one over here, for 1, 2, we're just focusing on rewriting it. So we're going to take this and throw it in front. The 6th root of x. And you can put the 1, but you don't have to. So the same thing happens here. 1/5 really means the 5th root. And same deal, we're going to take that 4, put it on the outside, and then the 7, 6. All right? So the same thing happens in the reverse form, right? We're going to take the 4 and we're going to throw it here. Obviously, it's not r to the 4th, it would be r to the 4th. There's technically a 1 here right now. Now for this one, you have the 3rd root of 27. Well, I know what the 3rd root of 27 is. It's 3. And 3 squared is 9. Okay, now you could also think about this as 27 to the 2/3. Okay, it's the exact same thing as we were writing in number 4. Okay, but you could also type that in and you would get 9. Okay, so multiple ways to look at that. All right, so this one, they have a bunch of different ones. We're just going to write each one separate. So it would be 5 to the 1/7, a to the 2/7, and y to the 4/7. All right, so for the next part, we are going to write the following in radical form, and then we are going to actually evaluate it. Okay, so for this one, radical form, remember we're going to take that product, throw it in front, and now we have 32 squared. Okay, now we can write it more like what we did up here, right? So you're welcome to write it. Okay, but it's easier most of the time to throw these squares or the numerator on the outside, because now when we're evaluating it, well, the 5th of 32 I know is 2. So I'm really just going to 2 squared, which Otherwise, you would have to do 30 squared and take the of 4. Okay. Either way, you get the same thing. I'm going to continue doing it this route. Okay. So for this one, take the 3, throw it in front. So we have the third root of 8 and then square. Well, the third root of 8 is 2, is 4. So we're back at 4 again. All right, and then we have the last one like this. I'm going to take 3 and throw it out in front. We have the third root of 216 and then squared. Third root of 216 is 6. 6 squared, 36. Okay, so again, routes to go for this. It's kind of up to you, whatever way you want to look at it. Remember that you could always type this into your calculator as well by doing 216 and then the caret. Just make sure you do parentheses 2 divided by 3 if you don't have one that automatically like puts a little box here. So just be careful with how you write it or type it in, I should say. All right, so go ahead and try these 3 on your own. It is a little different, so you might want to watch 1 before you try it. The only thing that's really different is the negative out in front. So we're still going to do the fourth root of 81, and then we're going to raise it to the negative 1 power. Okay, so the fourth root of 81 is actually 3, and you could type that into your calculator, and that's fine. Okay, or you can know it's 9 times 9, which is 4 3s, right? And remember, I can't have a negative exponent, so this changes to 1/3. Again, you could have 1 over 3 to the 1. That's totally fine too. So the next one is done the same way. The 8th root of 256 to the negative 3. Well, the 8th root of 256 is 2, I believe. Let me see. I want to check to make sure. Yeah, I think so. Yep, it is. It's 2. So we have 2 to the negative 3, right? So what I would do is say, okay, well, let's put it as a positive 3. So it's 1 over 2 to the 3rd, which is 1 over 8. And then same thing for the next one. We have the second root. Remember, you don't have to write that to the negative 1, which would be 7 to the negative 1, which is 1 over 7. Okay, so hopefully we feel pretty good about rewriting them in the different forms. So now we are going to simplify the following. Okay, so we're going to find the prime factorization and then use radical exponents to simplify. Okay, so this was kind of used on 7.5. So essentially what we're trying to do is we're trying to rewrite 49 in a different way. Well, I know 49 is 7 squared. So we really have the fourth root of 7 squared, right? So if we rewrite that as a fractional exponent, that would be 2 over 4, which I can reduce to 1/2. Okay, so it really is 7 to the 1/2, which we should rewrite as the square root of 7. Same rules apply on the next one. 144, we know that's actually 12 squared. So we have the fourth root of 12 squared, which is really 12 to the 2 over 4, which is 12 to the 1/2. So we're really at the square root of 12. Now, from here, yes, we could be done, but this one we can actually break down into 4 times 3, 2 times 2. So we get 2 root 3 as my final. All right, so we're going to use the properties of exponents to find the following, and then we're going to leave our answers in radical form. So we need radicals in the end. Okay, so for this first one, we are going to add those exponents. So it would be p to the 10 over 4, which I can reduce to p to the 5 over 2, which then we need to put in radical form. When we do that, we're going to take that 2 out in front. So we get the square root of p to the 5th. Now again, you can always write it as the square root of p to the 5th. Same thing. Obviously, this one just looks a little nicer if it's on the inside. For number 17, ones like this, we are multiplying the exponents. So we have x to the 4 over 9, which I can't reduce at all. So I'm just going to take that 9 and put it in front. So we have the 9th root of x to the 4th. On the next one, we are going to subtract these, right? You have to think which one's the bigger one, which 1/2 is bigger than 1/3, but we need a common denominator. So we need 6. 1/2 would turn into 3/6, and 1/3 would turn into 2/6. So we're left with 1/6. Now this goes where the larger one's at, which is the numerator. So it's x to the 1/6 in the numerator, which becomes the 6th root of x. On the next one, we have the 3rd root of 16x to the 4th. Okay, so we can just try to clean up some of this. Obviously, 16 is 4 times 4, and 2 times 2, 2 times 2. So we can take out a group of 2's, and you're left with 1 on the inside. And then we have the 3rd root of x to the 4th. So I need to be divisible by 3, so I need to take 1 out. So I'd have x and then the 3rd root of x. So we have 2x, 3rd root of 2x. And then we have the next one. So for this one, I know I can divide 16 by 8. I can't divide 2 by 8. I can't break down 25 that nicely, but we will be able to clean it up more. So focusing on this one, I know that that can become x squared on the outside. So then we're left with the 8th root of 25, which is 5 squared, and y squared, right? Now, because both of those are squares, I know that the radical can turn into the same thing. Both of these would be 2 over 8, which means both of them would reduce to 1 over 4, or the 4th root of 5y. So my final answer would be x squared that I got from the start, and then the 4th root of 5y. This next page, I'm actually going to end up skipping these ones over here with you. They get a little overcomplicated, and it's not the focus of today. So I want to just finish off with the last two. And these last two are more like what you'll see and have to be able to manipulate. So all we need to do is rewrite these with radicals. So we're going to throw that 6 out in front. So we have 6 root of b to the -5, right? So again, you could put the -5 on the inside, but in reality, the whole thing's being raised to the -1 power at least. So if you wanted to think about it, it would be the 6th root of b to the 5th to the -1, okay? Either way, you would end up with the answer of needing to put it in the denominator, and you can either write it that way or you could write it this way. Okay, both is acceptable. So number 26 is actually done the exact same way. We're going to take the 5, throw it out in front. So we have the 5th root of r to the -4th. So we need to throw it in the denominator, and we have the 5th root of r to the 4th in the denominator. Or, remember, the 5th root of r and then to the 4th. Both are the same.